In this video, we get to move on to chapter 5, which I'm really excited about because this is getting into ways we use integrals. So some really cool business applications of how integrals can actually help us. And the first one we're going to talk about is something called consumer and producer surplus. So what are these things? Well, let's say you run an Etsy shop. And after putting a lot of research into it, you're able to find that your product that you're making has the following demand equation. Okay? But we are going to switch it up a little bit. X represents the number of products you make. And D of X represents the price. Usually, a lot of times, P is the price, and that's your independent variable, and then the demand depends on that. But this is opposite. So X represents the number that you want to sell, or you're going to sell, and D of X will be the price that you need to set it at. Okay. Well, if I look at this on a graph, this, of course, just gives me a decreasing linear function that crosses the y-axis at 450, right? That represents the price you should sell it at if you want nobody to buy it, right? If you want nobody to buy your product. Let's say you decide based off of this, you decide, hey, I want to sell 3 products in a year, okay? Well, if I plug 3 in, I get 225. So what does that mean? That means I should sell my product for $225. Okay. So, we might be thinking, okay, so how does this actually relate to integrals? Well, now that we've decided, okay, I'm going to set my price to $225 because I want to sell 3 products, let's actually take the integral of this. The definite integral from 0 to 3 of my demand function. Mathematically, what are we doing? We're finding the area under the curve from 0 to 3. Well, if I plug this into my calculator, right? If I use the fundamental theorem of calculus here to evaluate this, I'm going to get 450x minus 75 over 3 x squared, not over 3, over 2. 75 over 2 x squared, and I need to evaluate that from 0 to 3. When I plug 3 in, I get 1,112.5. And when I plug in 0, I get 0. So that's what I'm left with. What does this number represent? Well, the demand curve represents what are consumers willing to pay for your for a certain number of products, right? What are they willing to pay for one product? What are they willing to pay for 1.5 products? What are they willing to pay, right? That's what the demand curve tells us. So, if I find the area under the curve, it's going to give me a total amount. This amount right here represents the total amount consumers are willing to pay for, in our case, 3 products, okay, for 3 products. So consumers are willing to pay over $1,000 for 3 products based off of the demand curve that you have. What's interesting, though, is this is actually not what they actually pay. Because if I set the price at $225, the actual amount they pay, here, let's do this in green, the actual amount they pay can be calculated straight out by doing price times quantity. What did you set the price at? You set the price at $225. How many are they buying? according to my demand curve, they're buying 3 products. 225 times 3 gives me $675. So that's a very different number than the actual amount consumers pay. Okay. If I take a look at my graph, what did I actually do here? Well, 3 times 225 gives me the area of this rectangle. The area of this rectangle is 675. The area under the curve is 1,100 or 1,012 and 50 cents. Okay. So what is consumer surplus? Consumer surplus is this region. What's left over, or what's the difference? So this region right here is considered my consumer surplus. Okay? So, let me define that here. Consumer surplus is the difference between the price that consumers are willing to pay, and sorry, not price, the total amount. That would be more appropriate. So between the total amount that consumers are willing to pay and what they actually pay. Okay, so in our case, our consumer surplus would be $1,012.50 minus 675, and I get $337.50. Okay, so this number right here is a measure of, you can kind of think about it as, how good of a deal do you think, do the consumers think they got? How much did they find this purchase a good value? That's what that consumer surplus actually represents. Okay, so the larger the number, the more the consumers are going to feel like, oh, they got a good deal on this. The smaller the number means, the less good consumers are going to feel about it, right? The smaller your consumer surplus, the less good that consumers are going to feel about that purchase, if that makes sense. So that's consumer surplus. Well, it turns out there's also a concept called producer surplus. So let's generalize this now for any situation. If you have a demand curve, using integration, we can solve for the area under that demand curve to certain bounds. Okay, but we always start at 0 with consumer surplus. Okay, so 0 to B, that's going to give me the amount that the total amount consumers are willing to pay, and what I'll do is I'll subtract it by the total amount that they do pay, which of course is just quantity times price. X is my quantity, D of X is my price. And that gives me my consumer surplus. Notice that this part isn't part of my integral, so I don't need to integrate that. I only need to integrate that first piece. So it turns out a similar concept exists for producers producing products. Okay, in economics, we've talked about demand curves quite a bit, right? That's what this was. Demand curves are all about how the price you set it at affects consumer demand. But it turns out that the price you set something at also affects your supply. Okay? Let's say you've got this Etsy shop where you're selling a product, and let's just say, I don't know, it's a handbag. It's a really cool multi-purpose handbag, homemade. If you're not going to sell it for very much, then your profit margin isn't going to be very large. The smaller your profit margin, the less willing you are to make lots of handbags, right? If you're not going to have a very high profit margin, you might make one just as like a fun little side gig. But if you can make that profit margin bigger, then of course you're going to want to make more. You might even make it a full-time job if you can get that profit margin really large. So this represents what's called the supply curve. And let's say in your case, your supply curve is 50 plus 25x. Okay. Notice that supply curves are usually increasing because the more you charge for the your product. So in our case, the more that I end up charging for these handbags, the more I'm willing to make, right? If I charge more, my profit margin is going to be bigger, and I'm willing to make more. Okay, so the supply equations are customarily increasing functions. Okay. Well, once again, let's look at what the integral of this would represent. Okay, so let's do from 0 to 3 again. So let's say, once again, I'm planning on making 3 handbags. If I actually plug 3 in here, right, if I calculate this at 3, I get 125. What does that actually mean? That means if I'm charging 125, I'm going to be willing to put in the effort to produce 3 handbags. Okay? If I'm going to charge 125. Now, I know you might already be thinking about the consumer demand. Let's ignore the consumer demand for a second. I promise we'll come back to that. Okay, so when I actually calculate this integral, let's see, I get 50x plus 25 over 2x squared evaluated from 0 to 3. And when I plug 3 in, I get $262.50. Okay, what does this value mean? Okay. What does this value mean? Well, it means something similar to what we talked about in consumer surplus. Okay, this represents the total amount of revenue the supplier is willing to take in order to make 3 products. In our case, handbags, right? And since it's an Etsy shop, you're the supplier. You're the one making the handbags. Okay. Once again, there's that idea of willing. It's what you're willing to do. So in both cases, the integral piece represented what the person was willing to do. Okay. And once again, similarly, this is not going to match the actual amount. Okay. If you set the price at 125 and produce 3 bags, if we assume that you're going to sell those 3 bags, what's the actual amount of revenue you're going to take in? Okay. The actual revenue is equal to, once again, price times quantity. In our case, that's just x times S of x. And you get 3 times 125, which is, of course, 375. So you're willing, in order for you to make 3 products, you're willing to just take $260.50, but you end up making $375. So this represents producer surplus. Producer surplus is the difference between what the supplier is willing to earn and what they actually earn. So in our case, right? That would be $375 minus $260.50. Pop, pop, pop. Which ends up being $112.50. So notice in both cases, with producer surplus and consumer surplus, those surpluses were both positive. You will actually never find an example where the surplus ends up being negative, because what that would mean is that somehow the consumer was cheated, or somehow the producer was cheated to where they made less than what they wanted, they were willing to. Or for a consumer side, they paid more than what they were willing to. We're assuming that the consumer will never pay more than what they're willing to, and the supplier will never produce more than what they're willing to. So these surplus values will always be positive. So let's take a look at graphically what's happening with my producer surplus. Okay. So with producer surplus, this is still number of products. Your x-axis still represents number of products, and your y-axis represents the price. It still represents price, but it's the price that you're setting, and that determines how many you're willing to make. So with our problem in this case, we started at 50, and we're going up by 25x. So now I have an increasing function. Okay, and once again we highlighted producing 3 products, and we decided that we should sell it at a cost of 125. Okay, so what did we do here? Well, the integral represents once again the area under the curve. Okay. But the actual amount that we earned, you'll notice in this case, it's this rectangle, right? $125 times 3. So in this case, the actual amount that I earned was more than the amount that I was willing to earn. And that's why with this case, we started with the actual amount and subtracted what we were willing to earn. Okay. And what does that give us? That gives us this little area right here, and this represents producer surplus. This just represents how good the producer is going to be feeling producing that many products. Okay. So now let's generalize producer surplus. To calculate producer surplus, it's going to look very similar to consumer surplus, but because I'm working with an increasing function, I'm going to start with my actual amount. So my actual amount that I earn is x times s of x, right? Price times quantity. Here's my price, here's my quantity. And then because I'm looking for the difference, I'm going to subtract the actual, or the amount that I'm willing to, which is the area under the curve. So 0 to b. Once again, I always start at 0, and b just represents however many products you're going to make. And this will give you your producer surplus. Perfect. So now let's put these two things together. Okay? We had our consumer demand equation that was an decreasing equation, and then I had my producer equation, which was an increasing equation. And let's say we go ahead and decide we're going to produce 3 products. I feel like I can handle that in one, and let's say this is over the course of 1 month. I can handle that in 1 month. I'm going to produce 3 products. Well, it's interesting because according to my consumer demand equation, you can sell 3 products if you set the price at $2.25. Okay, so if I want to sell 3 products, I want to sell 3 handbags, maybe I should set the price at $225. But that didn't match what it was for the supply equation. According to the supply equation, you're willing... I would still make 3 handbags even if I was only selling them for $125. So, which one do I pick? Which one do I pick? Well, if I look at this on a graph, if I pick, let's say, as a supplier, it might seem obvious which one to pick. Oh, well, if I know if I can sell 3 handbags at $225, then of course I'm going to sell it for a higher price, because that means I can make more money. So let's do that. Let's sell it for $225. Remember that this rectangle, the area of this rectangle, represents the actual amount of money that you're going to make. The actual amount of revenue that's going to come in. Where's your consumer surplus? Here's your consumer surplus. Where's your supplier surplus? Your producer surplus? Here's your producer surplus. Notice how much bigger the producer surplus is than the consumer surplus. There's still consumer surplus, so there's still going to be some consumers that feel like they got a good deal, but the smaller that consumer surplus is, the less they're going to enjoy that transaction, or the less they're going to actually feel good about that transaction. If they don't feel as good about it, they're not as likely to recommend it to their friends, right? So sure, your profit margin's amazing, but you're sacrificing some consumer surplus. That also means that, sure, they may not be recommending it to their friends, but that also means that there's some people that like your handbags and want to buy your handbags, but think they're too expensive, and so they don't. So, by setting the price at $225, we have what's called some deadweight loss. Okay. We have deadweight loss because there are some consumers that want to buy it, but won't because it's too expensive. Okay. Well, in that case, maybe we switch it up. Maybe you're feeling kind, and let's say, never mind, scratch that. We're going to sell it at $125. We're going to sell it at $125. I'm still willing to make, you're still willing to make 3 handbags even if you sell it at $125, so heck, let's go ahead and do that. What does that do? Okay, well, now the actual amount that I'm going to make represents this area, which we already calculated. It's $375. That's how much I'm actually going to make. And I still have some producer surplus, so that's still more than what I was maybe willing to do. Okay, but notice how that changes the consumer surplus. Now the consumer surplus is massive. Okay, which means consumers feel like they're getting an amazing deal from this. This is way cheaper than they planned on it being. They're getting an amazing deal. They're referring it to their friends. They're saying, hey, you got to get one of these handbags. But remember, you as the supplier are only willing to make 3, because otherwise it's not worth your time with how much you've set the price at. What does that mean? That means you're probably going to run into shortages. You're going to have a large demand of lots of people wanting these handbags, but you're not going to be producing enough. So once again, we experience deadweight loss. There are consumers who want to buy your handbags but can't because you don't produce enough. Deadweight loss. Okay, so how do we prevent this deadweight loss? Well, I know you guys have probably been wondering this from the time I drew this graph, but what if we choose this point where the 2 graphs meet? If we choose the spot where the 2 graphs meet, that means we're satisfying both the supply equation and the demand equation. And theoretically, if we do that, we reach what's called a state of equilibrium. We still have a significant consumer surplus, so consumers still feel like it's a good deal. They're happy about their purchase. They're willing to refer other people. But you as the producer feel like it's worth your time and worth your efforts to produce that many products. And so both consumers and producers leave feeling satisfied, and the market is in what's called equilibrium. So this point right here where the two curves meet represent my equilibrium point. By using the equilibrium point, we prevent any deadweight loss. Let's recap. By choosing to produce 3 products, I wasn't at my equilibrium point, and I experienced deadweight loss. So instead, I want to find my equilibrium point. How do I find this equilibrium point? Well, remember, the equilibrium point is where the two graphs meet. So recall, my demand equation was equal to 450 minus 75x, and my supply equation was equal to 50 plus 25x. How do I find where they cross? I can just set them equal to each other. So I'm going to do demand equation equals my supply equation. Okay. So in our case, 450 minus 75x equals 50 plus 25x. Move some things around. I'll add 75x to this side. I get 100x. I'll subtract 50 over on the other side. I get 400. Divide by 100, and I get x equals 4. So my equilibrium point is I need to make 4 products. If I do that, I won't experience deadweight loss. It'll be the optimal point where the consumers will feel really good about the purchase, and you as the supplier will also feel really good about the production. Let's look at an example from your homework. So this is number 6. And you'll notice it gives you a demand equation and it gives you a supply equation. Now, what's nice about your homework is every single problem is the exact same problem. All they do is they just change up the demand equation and the supply equation. So all 3 equations are asking the same all of your homework problems are asking the same 3 things. First, find the equilibrium point. Because once again, we want to find that equilibrium point so we prevent any deadweight loss. And then second, find the consumer surplus. And third, of course, the producer surplus. So all of your homework problems are all structured the same exact way. I want to do number 6, though, because 6 has a kind of a fun extra thing to worry about. It can be a little tricky, so let's talk about this one. So first thing I need to do is I need to find my equilibrium point. And how do I do that? Like I said, just in that last example, I can do that just by setting my 2 equations equal to each other. Set your supply equation equal to your demand equation to find the optimal amount of products you should produce. Okay. How do I deal with this, though? I've got 6 minus x on one side and a square root of an x plus 6 on the other side. Well, the biggest problem here is that square root, so I'm going to get rid of it. How? By just squaring this whole side. But if I do that to one side of my equal sign, I have to do that to the other side of my equal sign. Okay, that gives me 6 minus x squared, which I can go ahead and expand out. Okay, that gives me 36 minus 12x plus x squared. That's 6 minus x times 6 minus x equals, the square root and the square cancel out, and I'm just left with x plus 6. Remember, you cannot just distribute this square because of the subtraction. You can't distribute that square. Okay. And now, of course, I can get everything over. Since I'm working with a quadratic function, I need to get everything over onto one side. And that leaves me with x squared minus 13x plus 30 equals 0. Okay. Okie doke. I now have a quadratic function set equals 0, which means I can factor to solve this, or I can use the quadratic formula, but this actually factors pretty nicely. This factors into x minus 10 times x minus 3. Interesting, though. That gives me 2 different answers, 3 and 10. How am I supposed to know which one gives me the optimal amount? which one do I use? Which one is the equilibrium point, 3 or 10? Well, test out some of them. Okay, if you plug in 10 to the supply equation, you get square root of 16, 4. Okay, awesome. That means I should set the price to $4. If you plug in 10 to the demand equation, you get 6 minus 10, negative 4? I can't set my price to a negative value. Negative values don't make any sense in this context. So I can't use 10. I have to use 3. So there's my equilibrium point at x equals 3. So that means when I actually calculate the consumer demand and the producer demand, so let's just start the consumer demand. I'm going to take the integral of my consumer demand equation, right? That's my d of x. What are my bounds? I always start at 0, and my equilibrium point tells me where I'm going to stop. So I'm going to go from 0 to 3 of 6 minus x dx, and then, of course, I subtract the actual amount I earn. Okay. Price times quantity. Well, what's my quantity? My quantity is this x value here. What's my price? Well, to get that, I have to plug it into d of x. So my price is what I get when I actually plug it into the demand equation. So d of 3 is equal to 6 minus 3, which is just 3. If I'm doing my producer surplus, same process. When you do price times quantity, your quantity is still the same. Your quantity is still this same equilibrium point. So my quantity is still 3. What's my price? Well, I could go ahead and plug it into S of x to figure it out. But the whole point of the equilibrium point is that the price that I'm getting out for the demand equation, for the consumer demand equation, should match the price that I'm getting out from my supplier equation. So what price do I need to set it at? I'm still setting it at the price of 3. Okay, so those two values should be the same in both consumer demand and supplier demand. But now, to finish this off, I'm just subtracting by the integral from 0 to 3 of my supply equation. And I'll let you guys work through that. Okay, let me know if you have any questions, and I'll see you in the next video.